All right. I'd like to thank everyone for taking the time to attend today. My name is Lance Zurich, and today we're going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, each of these sets are designed for conducting a project-based class, and this is where students will be required to design and build a series of original prototypes based upon their own research and their own activities. And each set includes standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert Tom White. So today we're going to start off where so many technology-focused presentations for education seem to start these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or the need for better STEM education in the schools, STEM, of course, being an acronym which stands for science, technology, engineering, and mathematics, well, what they are essentially talking about is the urgent need to prepare our students with the background they need to successfully compete in the job market that they're going to graduate into. In the employment market that once greeted our grandparents or perhaps even our parents, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming, automation, IoT, and rapid advances in all aspects of technology. In short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. This is, of course, why so much of the emphasis in education over the last decade has been on developing STEM skills. Now, every new advantage that we enjoy, such as, for example, the tablets and the smartphones that we all use daily, was created because of individuals who helped to make those advances. Countries all around the globe, countries like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. Now, here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to be part of the next wave of advancements we rely on to stay competitive on the world stage and to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, what we're going to do right now is to move right along to the main topic, which is, of course, mechatronics. Mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. Well, just how prized are these skills? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they need to start developing the habits and the career focus as early on as possible in their education, in high school, if not even in middle school. Now, the dilemma for educators, whether in the classroom or the homeschool, is finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process, and not just involved in memorizing obscure facts or ideas to take a few tests, then to promptly forget them. No. To best help students to be successful and to really encourage them to consider pursuing further education in subject matter such as this, educators need to be able to present the material in a way that makes it relevant, which means, of course, answering the eternal student question, why do we need to know this? And it also needs to be engaging in a way that holds students' attention better than rote notebooks and lecture presentations, and something that has visible real-world applications in which the students can get involved with doing things hands-on. Now, it's with this dilemma in mind that we created the Studica Mechatronics programs. These two special sets, one designed as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to the subject, were created to provide all of the materials in one place that educators will need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and which is crafted to meet current academic standards. Each of the two Studica Mechatronic Program sets comes with its own detailed day-by-day curriculum document created especially for Studica by noted educator and STEM expert Tom White. The curriculum itself comes as a downloadable PDF, which is available for free with the purchase of each set. This curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. The curriculum is also designed for offering a project-based learning program, and this means that solving the problems that arise in each unit requires the students to be actively involved in the research, actively involved in the design, in the trial and error experimentation activities, as well as the building of actual working prototypes that will provide the required answers. And students won't do this alone. They'll be asked to work in small groups or teams of 4 students each. And this is designed to help develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And by soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable programming software, each set includes all of the physical building materials each group will need to enable it to address all of the design projects presented throughout the course of the curriculum. The curriculum is designed to enable teachers of all backgrounds, and this includes teachers from non-science or technology-focused disciplines. It's again, to enable teachers from all types of backgrounds to have the information they need at hand to properly prepare them for conducting the activities, and to increase their comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system they will use to address the projects presented in each of these units. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario where students must work together in small teams, again, teams of 4 students, to create a solution to the problem. The project units each contain embedded academics. At the end of each unit, the students will be required to make a formal presentation of the prototype they have created to address that particular unit's real-world scenario and explain the reasoning behind the way they constructed their prototype. There is a technical literacy task driven by each of these projects. As students work to address each project, they will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. Now again, as required by each project, students will be asked to create original prototypes. They're going to be asked to create any required programming-based solutions, and also they need to maintain detailed documentation during the entire process. Now, as I mentioned a few times in this presentation, the curriculum that accompanies each of the Mechatronic program sets was created especially for Studica by a man named Tom White, and you see a picture of Tom right here on the screen. Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs both for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards that are currently in place in the United States. And this includes the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. And as I mentioned earlier, the programs are designed to be project-based. When students ask, why do we need to know this? It's usually because the subject matter that they're being presented with might come across as being too abstract to ever be useful in their lives. Now, with this project-based approach, students get to see firsthand why these things are necessary and why they're going to be useful. The concept of working in the small groups to solve the project problems also helps students to develop the high demand soft skills that employers look for. Again, skills like communication, analytical skills, quantitative skills, flexibility, adaptability, and problem solving. In this project-based format, all of the subject matter is integrated. That means the math is integrated with the reading and the writing and so on, which is of course ideal for STEM education. Also, because of the manner in which students must approach each of these projects put forth in the curriculum, again, with the research, the testing, and the group give and take, that just to provide a few examples, because of this, it allows for a much deeper exploration of problems than traditional teaching methods might allow. The projects presented in each unit are also designed so that if you have several groups working on the same project, you should see variations in the prototypes and in the solutions being presented to you. Now, this could, of course, be because of differences in creativity or differences in research or approaches taken by each of these groups. But in any case, students can see firsthand that problems can have many different answers, and that often there is not only one right answer. Each project in the curriculum presents students with the opportunity to plan, to organize, and conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Research that is utilized in the design, the prototyping, the testing, evaluation, and redesign phases of each of these solutions. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough material for teams of 4 students. The team approach, as stated before, helps to promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And once again, everything you need to conduct the program, with the exception of the programming software, as I've mentioned before, is inside each box. Access to the free curriculum download is included with the purchase of each set in any quantity. And also included are all the building materials which students will use in the creation of each of their prototypes. The materials that they're going to use for the building are from the unique Fisher-Technic building system, and among the components included in each set are 2 robotic controllers and power supplies, and you'll see a picture of the one robotic controller right up here. Now, this might beg the question, so what is Fisher-Technic that I just mentioned? Well, as many of you may not be familiar with it, let me provide you with just a little bit of background. Fisher-Technic is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, Fisher-Technic was created with more of an engineering mindset. The core building block in the Fisher-Technic system is unique in that it allows attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place, using a tongue and groove assembly method. The system also includes a wide selection of very specific parts, variations on gears and girders, sensors, and lots more. And because of this, it allows technical builders to address equally specific design needs. Fisher-Technic was originally developed back in the 1960s by German inventor Arthur Fisher, who you see here, who's noted for countless innovations used in the construction and the automotive industries. Mr. Fisher, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher-Technic, Mr. Fisher was the inventor of synchronized flash photography back in 1949, as well as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction, as well as components used in automobile manufacturing, and they also are known for providing consulting services related to automated processes. Now, with all of that being said, let's begin looking at each of these two individual sets. We'll start off with the Studica Introduction to Mechatronics Program set, or for those of you who like acronyms, we'll refer to this one as SIMP. The set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. The curriculum contains enough activity material to fill approximately 45 academic hours. Now, with this in mind, we recommend this program set for insertion into regular related class activities, to be used as a short class unto itself, to be used for school after-school program use, or of course for homeschool use. Excuse me. The curriculum created for this set is standards focused, again, using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle or high school classes, or again, for addressing the same grade levels in a homeschool environment. The set contains a collection of over 700 Fisher Technic building components, and this means everything from gears, wheels, axles, blocks, sensors, and so much more, as well as 2 robotic controllers and 2 power supplies. Again, only the required robotic control software, which we will discuss at the end of the presentation, is not included, but again, it is very affordable and is available separately. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and these units are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, the conversion and storage of energy, and an introduction to control systems. And there are also activities included to address the following topic areas that come up during the course of the curriculum: sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, working with sensors such as the digital switch and the digital photo transistor, working with open loop and closed loop programming, with digital branching, learning about analog sensors such as the photocell LDR, working with analog branching, working with other analog sensors such as the NTC resistor and the and the potentiometer. Now, before we go further into the structure of the curriculum, let's first look at what is covered in the second set. And this is the Studica Teaching Applications of Mechatronics Program set. And in this case, the acronym would be STAMP. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. This set comes with access to a free downloadable 400+ page curriculum document, in this case entitled Mechatronic Applications, again by Tom White. The activity material in this curriculum document, when used in conjunction with the contents of this set, is designed to fill approximately 180 academic hours. So essentially, we're talking about 4 times the amount of academic hours as it was covered by the previous set. Now, as such, this set can be seen as a more expansive version of the material touched upon in the previous set, and is designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent, every week for a full academic year. Again, this set is designed for offering students a standards-focused, project-based learning experience, and is designed for use in middle school, high school, or for addressing similar grade levels in a homeschool setting. The materials in this set consist of a selection of over 1,200 Fisher Technic building components, And this once again includes a wide array of gears, blocks, sensors, axles, and so much more, as well as 2 robotic controllers and 2 power supplies. And again, software is required for this set and is sold separately. There are twice as many project units included in the Studica teaching applications of Mechatronics program set as we had with the previously discussed set. And this will include units on the following: sketching and documentation, simple machines, mechanical systems, basic electricity, followed by project units focusing on the creation of a garage door, of an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize. And these include sections on the following: sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the programming software and robotic controllers, open loop programming, sensors such as the digital switch and the digital photo transistor, closed loop programming, digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, and the potentiometer, and working with data. Now that we've had a look at each of these sets and how they differ and how the specific subject matter is covered by each, let's now look at exactly how the curriculum itself is structured. Both versions of the curriculum share the same format when it comes to the structure of each of the project units, and as already discussed, each version will include tutorial materials, activity materials, standards, and supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. What we mean by this is each unit is designed to clearly spell out everything being addressed, and again to provide tutorials and other information as the topics arise. Now, this was done specifically to enable teachers from all kinds of backgrounds. And again, this includes those teachers who come from a non-science or a non-technology focused background. Well, once again, it's designed to enable all of these teachers to quickly become comfortable with delivering the material simply by reviewing each section before you present it in class. So you won't require any special training. If you just review the material, use the links, you'll have the information you need. Each unit presented in the curriculum for each of these sets includes the following sections: the introduction, the purpose of the project, the concepts being addressed, an outline, the standards, assessment rubrics, the essential question, the student scenario, the daily plan, vocabulary, words and terms, and resources. Now we're going to look at each of these sections a little bit closer. The unit starts with an introductory section and the purpose of the project. Now, just as you would likely gather from that name, this is the section that provides a brief description of the topic that will be explored in the coming days and activities. And this is also the section that seeks to clearly spell out to the students why they are learning this material and why it's important for them to know. The next section focuses on the main concepts to be addressed in this particular unit. And these can be thought of as the broad ideas that will be explored in the unit and the core information that students should take from this project that will be essential for them to understand and utilize, not only today, but also to draw upon as they move forward in STEM fields of study, and of course, if they choose to follow it further, in STEM-related careers. Following this, we encounter the outline. Now, in this section, we drill down more specifically to what will be addressed in the unit. Now, as the example shown on the screen right now is taken from a unit that focuses on addressing aspects of programming, you will see that we touch upon areas such as the methods for writing programs, for example, flow charts, word problems, things of this nature, program characteristics, open or closed loop, working with branching, digital, analog, subprograms, and so on. The next section of each project unit focuses on the specific academic standards which will be addressed in that unit. Now, as you can see, this includes college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this will include both rubrics for the specific project being covered, along with general rubrics for literacy tasks. Next, we encounter the essential question. And this can be thought of as the big picture question that will be focused on in each of the smaller individual activities we're about to see. And of course, all of the aspects of the larger project, which students will be asked to complete in this section. Next up is the student scenario. And this is where the specifics of the project to be addressed are finally spelled out. This is presented in the context of a real-world style scenario where students are presented with a problem that needs to be solved with the creation of some sort of device or machine or mechanism or what have you. Now, as I mentioned before, students don't do this alone. They must work together in small teams of 4 to craft their answers to this challenge. Solving this problem will require each team of students to design a unique and original answer, which once again will usually be in the form of a working prototype, along with whatever programming might be required. Now, just to provide an example, if you look closely at the student scenario showing on the screen right now, you will see that the project in this unit has each group of students take on the role of a design team employed by a firm that manufactures garage door openers. Now, in this particular case, students are being required to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are all spelled out clearly, such as in this case, the use of limit switches, being able to meet certain safety standards that require a method for sensing if anything is in the way of a closing door, and also the incorporation of an automatic light. Now again, each team of students will be tasked with creating both a unique and original prototype, and in this case that means a garage door opening system, and as well as creating the programming needed to control that prototype. Now, as they move through the challenge being put forth in the scenario, each student team will be required to document the entire process in both a design notebook and a digital engineering journal. They're going to have to notate all of the research, keep track of all of the trial and error experiments, keep copies of all designs and sketches, as well as any revisions, and so on. And at the end of each project unit, each team of students will be required to make a formal presentation in front of the class, during which they will be asked to demonstrate their prototype and programming in action, much as they would be required to do so for an actual employer or client in the real world. The next section we encounter is the daily plan. This is the section that spells out clearly, both for students and for teachers, what's going to be expected of the students, how the teacher will conduct the day's classroom activities, and what specific subject matter is going to be covered. Now, some days might involve discussions, others may involve research or building small projects that help provide the building blocks, so to speak, that students will draw on to complete their larger projects as described in the student scenario. But in short, you can think of the daily plan as a roadmap designed to keep everyone on the same path. You will see too that along the way, as different aspects are addressed in each day's activities, such as, for example, what's required in a design notebook, or how to use the control software, or working with the controller, or even with flowcharts. As each of these things comes up, there are links to sections which will provide further instructions and information on each of these areas. At the completion of each unit, after the last day of the daily plan, is a section containing vocabulary, which are, of course, important words and terminology introduced during the project unit, as well as a selection of useful resource materials. And these resources can contain a mix of different types of material. It could be anything from carefully vetted websites and video links to PDF documents, PowerPoints, and much more. Besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to use the Fisher Technic building system. Now, this includes information on how the parts fit together using the pin and groove assembly method that I mentioned, identifying the different types of parts from the various types of girders and blocks, the different types of axles, gears, rivets, and so on. And students also get to build a very basic sample model to help familiarize them with the system before they move on to their projects in each of these units. And as learning about and maintaining proper documentation is one of the areas that's really stressed in this, there is a section which details just what defines each type of documentation listed on the screen now and what is required for each. And as the process of conducting this type of more open project-based class activity might be new to many teachers, there's also a section that discusses specifically project-based STEM education and its benefits. Now, as that completes our overview of these two sets, let's quickly review the contents and purpose of each set, but this time with pricing. First, we have the Studica Introduction to Mechatronics Program set, which is designed as a standards-focused, project-based introduction to the core concepts of mechatronics. Once again, it includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the building materials in this set, will provide teachers with enough academic material to fill approximately 45 academic hours. It is again designed for those educators who wish to offer a shorter class on the material, who wish to use it for after-school programs, or of course, those who wish to use it for homeschool use. The teaching materials designed for use in middle schools and high schools, as well as again by homeschooling parents seeking to address STEM and mechatronics for these specific grade levels. The physical materials in this set include a selection of over 700 components, again, including blocks, gears, sensors, and much, much more, all taken from the Fisher Technic building system, along with 2 robotic control units and 2 power supplies. These materials will again be used to construct the mechanical prototypes addressed in each project unit of the curriculum. Software is again required, and we will touch on that in just a minute. And I should also mention, all of these components that are being used in these programs, you can build a model, you can take it apart, and then you can build the next model. So everything is going to be reusable. So you won't need to repurchase things if you use it from semester to semester or what have you. As long as you obviously keep all your parts in order, you can just keep using this and reusing this. So again, each set is designed to be used by a team of 4 students at a time, and the pricing on these starts at just $699 for a single set. But of course, discount classroom pricing for groups of 20 students and up is available by quote upon request. Next, let's look again at the Studica Teaching Applications of Mechatronics Program set. Once again, this set is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, which is based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, written by noted STEM expert Tom White. Now, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. And this set is designed specifically for those teachers and homeschoolers who are able to dedicate a daily class period of 50 minutes per day, 5 days a week, or the equivalent, to this subject matter for a full academic year. The set is designed for use in middle schools and high schools, as well as, of course, by homeschooling parents seeking to address STEM and mechatronics for these grade levels. Each box contains an assortment of over 1,200 components from the Fisher Technic building system. Again, blocks, girders, gears, sensors, axles, and much more, as well as, again, 2 robotic control units and 2 power supplies. The required software is sold separately. We'll touch on it in just a second. Once again, each set is designed for use by teams of 4 students at a time, with pricing for a single set starting at just $799 per set. And again, discount classroom pricing for 20 students or more is available by quote upon request. And as I've mentioned the software that's required, let me address that as well. The software in question is Fisher-Technic RoboPro software, which is graphic programming software. And by this, it means that basically it uses a flowchart style design using various icons, which students arrange and link to create the programs used for each of these models. Now, this kind of software is ideal for teaching the fundamentals of programming to users of all levels. Pricing for a single unit license is only $36 per, and an unlimited single site school license, meaning that you can have unlimited users at a single site or building with this license. And by that we mean you could have 1 computer, you could have 100 computers, 200 or more if needed. And the cost for that site license is only $120 per site license. And please note that these are not subscription prices and they're not annual licenses. These are non-expiring licenses that you can access and use as long as you have the software disk which comes with each of these, and as long as you are able to install them on a compatible Windows-based desktop or laptop using Windows version 7, 8, or 10. Updates to this software can be downloaded free of charge to registered users from the manufacturer's website as they become available. So at this point, in case we do have any questions, I know everybody's been pretty patient. If you do have any questions, there would be 2 ways to go about asking. You could use the question and answer window, which is located on the Zoom toolbar, or you could use the chat window, also located on the Zoom toolbar. It's, I know on mine, it's under the ellipses way at the end. It might be located somewhere different for you if you're not a presenter, but either way, use either of those 2 windows. If you do have any questions, feel free to type them in now. Okay, I'm going to go once. I'm going to go twice. And I'll bring us to this slide, taking the next step. So if you're ready to take the next step, if you'd like to request a quote, or if you'd like to speak to the dedicated educational representative for your state to find out more about either of these 2 sets or any of the other educational solutions we offer, as well as a full line of Fisher-Technic education solutions, you can simply call us toll free at 888-561-7521, or if you prefer, you can also email us at info@studica.com. Now, if you have any specific questions about anything I've discussed, or maybe things I haven't touched upon today, or if you have any questions about Fisher-Technic and the line of Fisher-Technic education focused solutions for teaching about STEM and technology, you can also email me directly. My email, as you see up on the screen, is lance.zurek. So that's lance.zurek@studica.com. Feel free to email me directly and I'll be happy to answer any questions you might have. So on that note, I'd like to thank you all very much for taking the time to attend today's presentation, and we very much look forward to speaking to you soon. So have a great afternoon.